Hello, chemistry students. Once again, here we are in the Unit 1, Chemistry the Big Bang. This video is on lesson number 10. That's the atomic structure as it pertains to the atomic mass. So lesson 10. So again, just a reminder, when reading a periodic table, you've got the symbol, first letter is capital. If there's a second letter, it's lowercase. You've got the name, you've got the atomic number, and then what we're going to deal with now is this atomic mass. The atomic mass is a decimal number. It's a decimal number for a reason. It represents, if I took all the atoms of boron that are in the world, and I were to weigh all of them, and I were to divide it by how many there are, I would get a average number, which would not necessarily be the weight of all borons, but it'd be a number that was weighted. So what happens is the numbers that are on the periodic table are called, they're a weighted atomic mass. They're a mass that is averaged, but based on how many of those isotopes are found in nature. I'm going to show you as part of this video how that number is calculated, and you're going to get a chance with your practice to calculate some atomic masses of various elements from some data. So since we can't gather all the atoms, we can sample data. We can sample data and say how many of the atoms are, say, carbon 12 and how many are carbon 13. And get weights, kind of like your grades, your grade in class is a weighted grade. Summatives have a bigger weighting than the formatives. This is a weighted average, but it's based on how many are found in nature, and that changes. Here's a table that shows various different elements and how much of that atom is present in nature. So hydrogen has 3 isotopes: hydrogen 1, hydrogen 2, and hydrogen 3. Vast majority of the hydrogens are hydrogen 1. And hydrogen 1 has a mass of 1.0078 AMU. A very, very tiny amount of the hydrogens are hydrogen 2. That's deuterium. Hydrogen 2 is like 0.015% of all the ones naturally found in nature are hydrogen 2. And they weigh about twice as much because they have a neutron. They weigh about twice as much as the mass of hydrogen 1. But if you were to average those numbers, 1 plus 2 in half would be 1.5. That's not the way this works. This is a weighted average. You're going to take and determine how much of the overall weight came from hydrogen 1, how much of the overall weight came from hydrogen 2, and calculate that. So here's what you do. So what you're going to do is we're going to take for every single isotope of the atom, we're going to convert whatever the percentage is into a decimal equivalent. So if you had 99.95%, that would be 0.9995. You're going to have the number, the percent, color I get red here, let's see if this works. If we got 95%, you're going to divide it by 100, and you're going to say, well, that's going to be 0.9532. So you're going to convert it over to the decimal equivalent by dividing it by 100. Then what you're going to do is take that decimal equivalent, that relative abundance, and you're going to multiply it by the mass in AMU of the actual isotope. And then you're just going to add the numbers together. And then you're going to get the sum, whatever that sum is, that add them all together, that is going to be your atomic mass. So let's look at an example with your grade. I'm going to change this color because I don't like the color being red. Okay, so if you had a grade, you know you have 70% summative, 30% formative, and say 70%, that's your summative. Suppose you get let's say we'll make it where it skews good. You got 95% on all your summatives. But you don't like doing homework, so for the 30%, oh, it's doing a spiky thing. For 30%, say you have a let's pick a number, 45%. If I average those numbers together, it'd be 95 plus 45, that would be 150. So I'd have a 75 average if I just average all of them by number of points. But what you're going to do is we're going to take 0.70 times 95 and 0.30 times 45, and let's see what we get. I have a calculator here on my desk. So 0.7 times 95, that's going to be 66 and a half. Writing on a tablet is hard. And then 0.3 times 45, that's going to be 13 and a half. So if I add those together, 0, 0, 8. So I get 80. So my average, because the part that has a stronger weight, I have a better grade on, it's going to lean towards the mass of the part that has a stronger weight. What we're going to do here is you're going to be given data that looks like this. You're going to give you a series of isotopes. You're going to have the series of isotopes, and every single one of them, they're going to tell you what percent of the isotopes of all the atoms in nature are, in this case, neon 20, neon 21, and neon 22. These are only three isotopes of neon that are found in nature. You can see that 90% of the isotopes are neon 20, 9% is neon 22, and a very, very small amount is neon 21. So you expect when you average this together that you're going to get a number that's going to be closer to the 19.99. Definitely, this is one thing that catches people. Definitely, when you're doing an average, it's going to be between this number and this number. When you do an average, there's no way you can get a number that's smaller than 19.99244. There's no way you can get a number that's greater than 21.99138. Why do I say that? Every time we do this, there's going to be kids who are going to they're going to trust the calculator, going to trust the button, punch the buttons, and it's going to give you a number that's weird. And you're going to say, well, because I'm looking at these numbers, I know that what I have is accurate, and I'm going to write down that my average here is going to be 193. And you're like, that's not possible. It's going to be between the small number and the big number. So that's one way to check to see whether you've at least done it kind of right. Okay, so what would we do here? For this one, what we would do is take our percent of our first isotope, that was 90.51%, change it to the decimal, so now it's 90.9051, multiply times the mass of that isotope. See, that first isotope was 19.99244. Get a number. Now, I sig fig this. So this number is with 4 sig figs because this has 4. This has what? 7. So my answer is going to be for this plot, it's going to be 4. Then I take my 0.2%, my 0.27%. Divide that by 100, I get 0.0027 times the mass of the second isotope at 20.99395. And I get this number, and this number has 3 sig figs. Or sorry, 2 sig figs. Because 0.0027 has 2 sig figs. And then finally, I take my last number, which is the 9.22%, divide that by 100, and I get 0.0922. Multiply that by this mass, the 91.99138, and get that number, and then I add them up. And when I do that, the number that I get rounded to 2 digits past the decimal is 20.19. And if you look on the periodic table, which I have one here on my desk, periodic table for neon, the number on the periodic table I have is 20.18. So you should get a number when you're doing this, when you're talking, you know the element, you should get a number very, very close to what's on the periodic table that you have to use in class. So that's the concept of a weighted average. So what you're going to have now is a chance to practice a number of calculating the atomic mass or the weighted average of the various isotopes. That's all there is to lesson number 10. Good luck doing the homework, and I will see you in class tomorrow.